Welcome everyone to this session, and today we are going to discuss how to bake extended events recipes, hopefully without breaking a sweat. My name is Gianluca Sartori. I'm an independent SQL Server consultant, data platform MVP. I've been working with SQL Server for a very long time. I started with version 7 back in 1998. And currently I'm working as a DBA at a famous Formula One team in Italy. If you want to read my blog, you can find it at spaghettidba.com, and my handle on Twitter, if Twitter matters still, is at spaghettidba. Okay, so the agenda for today, this is very short because what we will see is why it's all about extended events nowadays. If you're still using Trace and Profiler, I hope to change your mind with this session. How many of you are still using Trace and Profiler? Okay, so I hope to, well, let's not say change your mind, but at least give you more options and see if there's an easier way to accomplish day-to-day tasks using extended events. What we will use for this is XESmartTarget, which is a small open source application that I wrote that will help you solve these day-to-day problems with ease. And then we're going to have a lot of demos. Actually, it's recipes, so I hope to keep you entertained with these. So first of all, if you've been using SQL Server professionally, you probably have used Trace more than once. You probably ran Profiler. This has been the go-to tool for understanding what is going on under the hood in SQL Server. But I will give you the news, Trace is dead. Because now it's all about extended events. Of course, SQL Trace still works, but extended events is the new way of doing things. Actually, it's not really new. It's been there for quite a long time. It was introduced first in 2008 to introduce another feature. It was introduced for building the foundations of the audit in SQL Server. Well, the first iteration of extended events wasn't really great. We had it already in the product in 2008, but it wasn't really usable. The tooling was really poor, and basically you had to write a lot of weird XML queries to get the contents of what was captured by extended events, and was really, really bad. Also, we didn't have all the events available in Trace. We had to wait a couple of versions before we had that. We had to wait until 2012. Hopefully you're not working with 2008. You're working with at least 2012. But if you're still using 2008 or even older versions of SQL, you probably need to use Trace. The idea behind introducing extended events for Microsoft was to give us a way to capture events that were not easy to capture with Trace. And this is feasible with extended events because it is nested very deep inside SQL OS and gives us the ability to monitor what is happening when a particular point in the code of SQL Server is reached. And at that point, some event will be raised in the extended events infrastructure, and you will have the chance to capture that event to understand what is going on inside SQL Server. Compared to SQL Trace, extended events has a lower performance overhead. So if you happen to fire your profiler at a busy production server and see performance take a dive, this will not happen with extended events. It is built in a way that if the load on the server is too much, it disconnects the captures. Another thing about using extended events over SQL Trace is that now Trace has been deprecated. So this doesn't mean it stopped working. It still works. But all the new events for the new features, all the good stuff is coming only to extended events. And also, if you are working in the cloud, there's no way there to set up a trace and capture what is going on. There's no way to fire profiler at an Azure SQL DB or an Azure MI. So the only way to capture events there is by using extended events. In MI, it works the same as on-prem. On Azure SQL DB, you have to do some magic in order to store the data. It has to be stored in blob storage. The same goes for MI as well. But the difference is that with MI, you have the ability to stream the events using the streaming API, which is what you get in SSMS when you right-click a session and you select Watch Live Data. That works relying on that streaming API. It has to be said that tooling has improved quite a lot compared to the beginnings. So now in SSMS, you also have things like the extended events profiler, you have better tooling. You don't have to run XML queries to see the contents of what is being captured by extended events. So the things are pretty good now. So the foundation of extended events is the targets. Well, of course, you have to define a session to see what type of events you are capturing. But one of the things that are really important when dealing with extended events is what you do with them. And that defines how you solve the problems related to these events. So if you have a look at the lists of possible targets from the documentation, you see that we have options to store the events in a ring buffer, so in memory. You can hold the events temporarily in memory to do some quick analysis. You can also write to a file. There's an event file target that allows you to write your events to a file, so you can go back later and analyze all the events in that file. And then you have special targets to accomplish particular tasks, like event pairing. This allows you to analyze events that usually come in pairs, like lock acquired or lock released, and things like that. Or then you have event tracing for Windows. There's a target that combines the power of extend events with event tracing for Windows. And then you have two types of targets that allow you to count events. There's the event counter that basically just counts whatever you throw at it. So whenever an event is captured by the counter target, the counter goes up by 1. You also have the ability to do that in a histogram target using one attribute from fields or actions to work as a group by for your event. So the events are grouped by that particular attributes and then counted, which is useful in some applications. So if you look at this list, there's a few things that should be obvious that are not here. For example, I would like to write events to a table, but there doesn't seem to be a way to do it with the built-in targets. I would like probably to get notified when an event is captured, maybe, so deadlocks or blocking. I would like to get a notification. There's no way to do it with the built-in targets. So this is why I built XESmartTarget. Basically, this is an open source application. You can find it here on GitHub, and you can go and download it. It's a small application. I promise it will not break your database. And what it does, it attaches to an extended events session, and using the streaming API, captures these events and will perform some actions in response to these events. And the goal is to extend the capabilities of the built-in targets to achieve the things that we saw were not present in the list of the built-in targets. So what we will do is we will use XESmartTarget to automate the response to some events. And the way we do it is by feeding XESmartTarget a configuration file that tells it how to respond to particular events. This is done with a JSON file. You don't have to write any code. All you have to do is have a look at the documentation for the targets and assign values to the properties of the targets to decide what is going to happen. Yes, we have a question. So the question is, does it work with analysis services? And the answer is, unfortunately, no. It will not work. It's only for SQL Server. Okay, so basically the idea is to create ways to respond to particular events and perform the actions we want to have performed when those events are captured. We have different types of responses. We have one to write to a CSV file, which is pretty simple. But then we have the main reason why I wrote this whole application, which is a table appended response capable of writing events directly to a table in a database. So you don't have to do any magic with XML or weird functions. Then we have the group table appended response that does the same, so writes to a table, but before doing so, aggregates the events in memory. Then we have a replay response that is capable of performing a replay. So when the event captured is an execution event, like RPC completed or SQL batch completed, you can take the text of the command and replay it on another server, maybe for testing or load testing, things like that. We have an email response that is capable of sending an email alert when a particular event is captured. This shouldn't be abused if you don't want to fill your mailbox. Then we have an execute T-SQL response that we will use to execute commands against the database, taking maybe attributes from the events that we captured and use them in the execution response. And then we have special response types to write to external types of databases. Telegraph appended response is used to write to an InfluxDB database using its agent, which is called Telegraph. And then we have the Guelph TCP response, which is used to write to oh my god, I forgot the name of this database. It's a logging database, specialized for logging. I don't remember the name. No, it's a different one. It's log something. Graylog. It's bad to get older, you forget things. Okay, and then we have the output stream appended response, which is capable of transforming the event and printing it to the standard output of the command in different ways, like a JSON or other possible formats. This is to allow other tools to capture that output and process it. Okay, so if you go to the documentation, which is linked here in the slides, you will see that the description of all the things that we mentioned. So there's links to the responses, and if you have a look at any of these, you will see all the properties available that you can set in a JSON configuration file. But we'll get to it in a minute. Good, so this is all the slides I had, because now it's all demos. Actually, it's all recipes. So let's try to bake something with these ingredients. So in order to do this, we will use a notebook. If you never saw what a notebook is, it works in Azure Data Studio and basically combines descriptive text with code, and all these code cells can be run. They have this run button that you can use to run whatever is coded here. You can select a kernel to run the code. So if it's like in this case PowerShell, we will select the PowerShell kernel, but we also have SQL kernels available. What we will do here is we will go through this document and run all the code that we have here. So this is good for demos or for documentation. So first of all, we're gonna have to go and download XESmartTarget. So let's go to its home page, we have the releases here link. So all we have to do is download whatever is available. So if you go here, we can download the MSI. Here it is already installed. One of the things that I should mention is that Windows might try to protect you from my sloppy code by saying this is dangerous, you shouldn't install it. Well, obviously you do it at your own risk, but I promise it doesn't do any sketchy stuff. The code is here, so if you want to have a look, it hopefully doesn't do anything dangerous. One thing that should be mentioned is that it doesn't need to be installed on the server. This can run on any machine that is capable of connecting to the server. So I have everything on my laptop for these demos, but I could be running it from my laptop installed here, and the server could be anywhere. It goes on the client, not on the server. Okay, so once we installed it, we can have a look at what gets installed. It goes to program files, XESmartTarget, and what you get is XESmartTarget.exe. This is the application we will use. Okay. The demos are available on my GitHub, so I want to show you that. My repository is here. I have this in code samples, so Spaghetti DBA code samples, and you have this baking extended events recipes available here. So you have the demos and the slides here. So if you want to play with it at home, you can do that. The only thing you will have to change is the name of the server you want to attach to and the path where the demos are saved. So in this case, this is the path on my computer. Before we go, I need to run this setup that creates all the things that I need to run these demos. And another thing that we will do is run this synthetic workload. This is called DS3. It is a synthetic workload that simulates the activity of an online DVD store. So kind of shows its age. It should be something about Netflix if it was done nowadays, but yeah, DVDs. I still have DVDs. Okay, so this will run in the background while we do our captures, and we will try to use this as the base for what we will try to examine. So this will perform its actions, and we will work with this as if it was a real workload. So the first thing that we will do is write all the events that we get to a CSV file and monitor it in real time. So why am I doing this? Because one of the things that people very attached to their profiler and trace always say, well, extended events is interesting, but with profiler, look how easy it is. I just have to double click profiler, it opens up, I just have to select one template and click start, and it goes, and I see all my events in a grid. So can you beat that? Well, kind of. So what we will do is we will set up profiler-like session, and we will use it to write the events to a CSV file, and we will observe the CSV file in real time, which is more or less what profiler does. And in order to show you how easy it is to do this with extended events, I will introduce another tool, which you probably know, which is DBA tools. This is a collection of PowerShell commands that you can use to run anything on SQL Server. Any maintenance and DBA activity that you can do with SSMS and much more can be done with DBA tools. And DBA tools has some commands to work with extended events. And Chris Lemaire, which is one of the main authors of DBA tools, took the time to scrape the internet for all existing templates for interesting sessions that you couldn't use with SQL Server, and even took the time to convert the profiler traces template to extended events and included all of that inside DBA tools. So if you have DBA tools installed and if you want to see all available templates, all you have to do is run this command, get DBA XE session template, and you can display that in a grid view. So if we do that, you will see that we have quite a lot of templates available, and some of them are coming from Profiler. So example, we have this, which is the default Profiler template, and we could use that to capture the events using extended events. So if we want to do that, all we have to do is import that session on our server. We will call it recipe01 using the template profiler standard. And then we will have to start that session. And you see it's 2 lines of code, super fast. And now we have this recipe. Oh, sorry, too many things open here. Should have closed all of this. No, I don't need that. I don't need that. I don't need that. Okay, and if we go here and we have a look at the sessions running here, now we have this recipe01 here created by our small PowerShell one-liner. Good, so now that the session is working, all we have to do is capture all the events and save them to a CSV file. And in order to do that, we will use XESmartTarget. We will use the CSV appended response to do that. And you have the links here in the notebook that take you to the documentation page for this particular response. And here we will see how you can configure XESmartTarget with a JSON file. So all we will have to do is run XESmartTarget.exe passing recipe01 output csv.json as the -- file parameter. We can also pass a log file parameter that decides where the logs are written. So let's have a look at the JSON file so we can see how easy it is to use. So a configuration file for XESmartTarget looks like this. There's a target object that needs to be populated and has the server name attribute that decides where the session is running, and the session name is the name of the session to attach to. Then we have a collection of responses. Here you can see this is a response. Is it big enough? Should I make it bigger? Can you read it at the back? Okay. You see this is a collection of responses, and the one we have here, we have just one in this collection, and it says it is a collection, a response of the type CSV appended response. So this has to be one of the names that I gave you at the beginning, the ones available in the documentation. And the CSV appended response, let's have a look at what it has as available properties. Here we also have an example that you can use to start your own experimentations. We have output file and overwrite and output columns attributes. So we can use these to set up our capture. Let's see what we have here. So the output file decides where it gets written. So we can populate this with any file on your computer. Overwrite, we set it to true. And then we have output columns. These are the attributes taken from the events. So the events we have in the profiler standard trace, actually session, so we have RPC completed, we have SQL batch completed, we have existing connection, what else, login. So we have a few events enabled, but we can filter which one we want with this event attribute that decides which ones are considered and which ones are not. So from these events, RPC completed and SQL batch completed, it will take the name, collection time, client application name, and all these will go to the output file that we are writing. All good? Are you still with me? Good. So let's try to do that. Let's run XESmartTarget and see what happens. It's a command line application, so it doesn't pop up any GUI, doesn't do anything fancy. It writes messages to a console. And it says, okay, initializing this response type, and then it says, I'm connecting, now I'm connected. And now it should be starting to write to the CSV file. Let's see if this is the case. So what we will do is we will open VS Code with that CSV file. And as you can see, it is writing to this CSV file. These are all the events that we have captured right now. And as you can see, it is updating itself. So it is a bit similar to the experience that we get in Profiler, isn't it? More or less, it does. It gets the job done. Okay, so let's move on. Do we have any questions? No questions, okay. I don't know if this is a good sign or not, but we'll see. We go now to the second recipe. This is the reason why I wrote this application, because I wanted to write events to a table in the database. I found it very frustrating that there wasn't a built-in way to write extended events directly to a table in the database. Yes, there's the ability to shred the XML from the session buffer. Yeah, oh yeah, we have a question. Okay. Okay, so the question is, can you control the size of the files, how many rollovers and stuff like that? The answer is no, but I can do that. If you need it, I can do that. Okay, so moving on. What are the possibilities if you have a normal extended event session and you want to use the built-in tools to write it to a table? You can shred the XML from the ring buffer, which is really painful. How many of you like to shred XML? Yeah, nobody, I knew. And the other possibility is to query this DMV that gets you the contents of the files from extended events. This is very CPU intensive, so and also you will have to find a way, if you want to do it over time, to get back to the point when you finished and pick up only the events that you are missing, if you want to do that in real time. So that has to be finished, the capture, if you want to have all the events available. Using the streaming API with XESmartTarget, you can do it in a real time using the table appended response. So let's see an example of this. We will set up a session for this, and we will capture all the events that are available in recipe 01. This time we do it explicitly with a create event session command. So we will include RPC completed and SQL batch completed events. And we will exclude the system commands. So let's try to do that. Let's run it. We have our session. Let's refresh here. And yes, we have recipe 02. So now, let's see how we do it with a JSON file. Okay, so no surprises here. This part remains the same. We just changed the name of the session. Now, in the responses, we have one response of the type table appended response. Here we have to populate the name of the server where we are writing the events, the name of the database, and the name of the table. We could let XESmartTarget create the target table for us, but the data types of the columns would be inferred from the data types, the .NET data types of the attributes. So this doesn't end well in many cases because string become nvarchar max columns, which are not easy to work with. So if you want, you can disable this behavior by setting auto create target table to false, and you can have to create your table up front with the correct data types. And here you can decide which events you want to capture. Which columns you want to capture from the events. These are matched with the names of the columns in the table in the database, and attributes with the same name will be written to that column. And again, you can decide which events to work on. So let's try to do that. We're going to start XESmartTarget. It's going to be here, saying it is connected. And now it says, okay, I'm writing events, 55 rows written, and you can configure the flush time, and every 30 seconds, or I don't remember how many, it just flashes on the table. Let's see if this is the case. Let's see if we have events in the table. So let's run this query. And as you can see, we have data flowing to our table. So I want to draw your attention to the fact that for RPC completed events, we got the statement column. But for, there we go, SQL batch completed events, we don't have it. We don't have the statement column, but we have the batch text. So in the extended events GUI, you have the ability to merge two columns. Has anybody tried that? You can create a merged column that contains batch text when there is batch text, and statement where there is statement. This is particularly handy if you want to have everything on a single column. So let's try to do that. We can do the same in XESmartTarget, and this takes us to the next recipe. So what we will do is we will take batch text for SQL batch completed events and statement for RPC completed events, and we will merge them in a single column. So before we do that, we have to create a session, and we'll do that by cloning a session with DBA tools. This is a very handy way to do that. We will copy recipe 02 and we will call it recipe 03. You can do it with just a few lines of PowerShell, so this is particularly handy. Basically, you have to export a session to a file, and then you can import that session again with the name that you want, and then you start that session. So it's super easy to do that. Okay, so now that we have it, in order to achieve this merged column, we have to use an expression in the columns. Let's see how this goes. So the JSON file this time contains, as you can see, more responses. We have a first response of the type table appended response, and then we have a second table appended response, and they work on separate events. The first one works on RPC completed events, and the second one works on SQL batch completed events. The total I/O column is defined as logical reads plus writes, and the SQL column is defined as statement for the RPC completed events and batch text for the SQL batch completed events. So this means that we will get these two columns in a single one by merging them this way. And the way this works is by defining an expression that works on the other available attributes of the events that we are capturing, and this expression is calculated at real time at runtime and assigned to the column name that we set here. Okay, so let's try to do that. Oh, I can stop this one. Let's try to do this. So let's start XESmartTarget, and now it says, okay, 6 rows written, 3 rows written. Let's have a look at what it is writing. And now we can see that everything goes to the SQL column, and total I/O contains reads plus writes. If we scroll down to a SQL batch completed event, there we go, SQL batch completed event. This also has, which one is it? 84. This also has the SQL column. So everything has been merged in a single column, which can be handy in some cases. Good. So any questions? No questions. Okay, let's move on and see another thing that we have to do over and over as DBAs. We had many ways of capturing blocking and deadlocking in SQL Server. We had many tools for this in the past. Now I will try to use XESmartTarget to accomplish this task. Basically, what we will do is we will use the email response to fire an alert and get an email when one of these interesting events is captured. So for that to happen, we will set up a session. First of all, we always needed a session, and we will use this blocked process report event and XML deadlock report event. So with this one, we will capture the deadlocks. With this one, we will capture blocking events. In order for this to fire, we need to set the blocked process threshold on our server. In this case, I will set this to 10 seconds. So every time a session is being blocked for more than 10 seconds, this event will fire. And we will get a notification every time one of these events is captured. Let's try to do that. So we have to start this to create the session, and now we have to receive the emails. For this demo, I will use Papercut, which is a nifty application. It's open source again, that allows you to have a sort of debugging email client that also contains an SMTP server. So it has everything collapsed in one. It is very useful for demos or for troubleshooting. Basically, the application will display the messages and also receive the messages as a regular SMTP server. So I'm going to start it and have it here waiting for new messages. I think it is here. Okay, there we go. So let's clear it. No cheating. It is here and it will wait for new messages. Okay, so let's have a look at a configuration file for this recipe. In this case, we are pointing to the recipe 04, and we are using a table appended response to write the blocking and deadlocking events to a table, but we are also using an email response that is capable of sending emails. All we have to configure is the address of the SMTP server, so localhost, who's the sender, so demo, and who it sends the notifications to, so the DBA at localhost. Subject, you can have the subject here, so deadlock occurred, and the body is, oh no, we got a deadlock. The attachment here, we set it to XML report. In this case, it will use one of the attributes from the events, in this case XML report. This will act as an attachment that we will call deadlock.xdl. So what I'm expecting here to get is an email with the message, oh no, we got a deadlock, and attached I will have the deadlock XML report. Let's see if this works. We're going to start XESmartTarget, and now all we need is some deadlocks. Probably your ERP is very capable of generating deadlocks, but we don't have it here, so I will have to run a script to generate some deadlocks. So it is running in the background, and I'm expecting to get some deadlocks. Let's see. Let's wait here patiently for some deadlocks. Nope, not happening. Oh, okay, we got a deadlock. Okay. So if we click here, we see the message that we are expecting. Okay, enough deadlocks. And let's stop the script. And yeah, so we got a message and it says, oh no, we got a deadlock. And through the sections here, we see that we have a deadlock.xdl. So let's have a look at this. And it contains the XML of the deadlock graph. If I download this and I save it as ctemp deadlock.xdl, yes, replace it, I can go to Management Studio and open ctemp deadlock.xdl, and it shows a nice, it shows a deadlock report. So you can use XSMS to inspect your deadlock if you are not comfortable with using the XML. Good, so it looks like it worked. Any questions? Okay, good. Let's go to the next recipe. This time what we will do is we will kill a sleeping and blocking session. So it happens from time to time that an application starts a transaction and then that transaction is left there doing nothing. The connection is sleeping, doing nothing. Maybe there's an error message displaying to the user, which is not clicking OK or cancel or anything, and the application is blocking many other sessions that are running on the server. So what would you do on something like that? Probably the only thing that you're left with is the possibility to kill that session. As a DBA, I would do that. So we can automate this, and the way we do it is by using XESmartTarget. Let's see how we can do it. We need a session, first of all. So we're going to capture, again, we need to configure the block process threshold to get these block process report events. And let's do that. So we have the session, and now we will use the execute T-SQL response. Let's see how this works. Basically, it has the ability to run any command, and how you do it is like this. The execute T-SQL response has a server name, so where we will run the command, the database name, so in this case master, and we will execute this. Execute kill blocker, passing the transaction ID taken from the event. You can use this syntax with the curly braces to take events from, take attributes from the events. So in this case, we're passing the transaction ID from the blocked process report event. And we will do that only for events that have a duration over 20 seconds. Okay, let's try to do that. Well, we can have a look at the stored procedure that we will run this. A kill blocker accepts a transaction ID, and that transaction ID is used to get the request session ID from the blocking session, and that note for a blocked session, and then we will use that to get the blocking session, and that blocking session will go to this SPID, and we will run this kill on that SPID. Okay, so let's try to do it. Let's start XESmartTarget, and now we have to create some blocking. So we're going to run 2 queries for that. I have a bunch of works here, and I will update in a transaction with no commit, no rollback. So the transaction is still open here, but it is doing nothing. The session is sitting there doing nothing. So if I try to query that table, now I'm blocked because I set this in read committed. This database is in read committed, so it has to wait for this session to release the lock on this row. There's only one row in this table. So if I didn't do anything, this would sleep forever because nobody is giving it commit or rollback. But as you can see, this executed at some point, and this is because XESmartTarget intercepted the blocking SPID event and run the command that we set up for blocking sessions. So now we got our result, and this one has been disconnected. Let's see if it's true. If I run this select one here, it says, oh no, this session has been broken, the connection has been broken. So in fact, this has been killed. Okay. Questions? Questions? No questions. Okay. Yes. Yes, so the question is, can we log it? Yes, you can combine multiple responses together. You can write that to a CSV file, to a table in the database, whatever you want. In this case, we made it simple. Okay, so let's move on. Let's close a few windows. Okay, another thing you probably want to do as a DBA is see who is connecting to the database, to the server. Imagine you inherit a big SQL Server instance. You have a lot of logins there, but you are not sure which ones are used and which ones are not. So one way to do this is to capture all the login events and save them, let's say, to an audit or to a file with extended events. You can do that. Or you can enable that in the error log. It becomes huge, but you can do that. The only problem with all these approaches is that what you get is not a description of who is active and who is not. What you get is the single events that tell you this login has logged into the server. But you're not interested in this. The only thing you want to know is of these logins available, which have been seen at least once in the observation period. So this is what you're interested. Probably you want to know how many times it logged in and which was the last time it logged in. These are the things you want. So in order to do that, we will use the group table appender response, which has the ability to capture these login events, and instead of writing them individually on the server, we'll increase the login count and increase the last login date. And we'll give you directly the report you're looking for without having to store all the individual events. So for that, we need a session. Let's have a look at the session we will use. And this time we will capture the SQL Server.login events. And these have everything that we need. We will include the client application name and the server principal name. So we can maybe group these events by application or the host name. Okay, so let's start the session. And now that it is working, let's see how we do this with a XESmartTarget JSON configuration file. So this time we are using a grouped table appended response. And we are writing to this server, to this database, and to this particular table, which is already there. So we are not creating it. And now we have these columns, the server principal name, database name, and client application name. And then we have these aggregated columns. So the minimum of the collection time is first seen. So the first time we saw this particular login. And maximum of collection time is the last time we saw it. And count of collection time is how many times the login itself has presented to the server. So now we are mixing aggregated and non-aggregated columns. What will happen here is that XESmartTarget will use the non-aggregated columns, so these ones, to match any existing rows in the destination table and will upsert the data there. So if we have existing rows, they will be increased. The minimum will get the minimum, the maximum will get the maximum of what is there and what is coming. And the count will increase by summing whatever is found on the target column. So let's try to do that. Let's start XESmartTarget. Now it is running, and we can have a look at the events that are flowing to the target table. Let's see if we get any data written. Should say rows written to the target. Doesn't say anything. Okay, let's try to see what we get. Nothing. Okay. Oh, we're getting some rows. So as you can see, this is my username, this is the database I connected to, and the application name is SSMS, first seen, last seen, and how many logon events have been captured. If I repeat this query again, I will see that I still have 2 logon events, but if I open some more windows, let's close them, all of these will be login events. So let's query again. You see the login count has gone up. So what it does, it groups by principal name, database name, and client application name, and summarizes these columns and merges the data with whatever is still on the tables, on the target tables. So this is pretty useful. I have my report for used and non-used logins already available. I don't have to do any fancy queries to extract it. If I leave this running for a significant amount of time, I could have the description of which logins are active and which ones are not on my server. This can also give you the ability to see which databases are used and which ones are not. You can see it with the database name here, which is another thing that it's not always obvious. Okay, so we could use the same technique on events to capture which objects are used in a database and which ones are not. We can do that by capturing lock events. This is a bit far-fetched. This is for experimentation. I would probably never do that on a server because there's a lot of events that get fired for lock acquired. But if you want, you can have intent exclusive and exclusive lock that can be considered as writes, and the others can be considered as reads. So if we summarize these, we can have a description of which tables are used and which ones are not. So if we start it and we use this JSON file to configure it, we can have the output here by these columns, and we can here have the last read for not mode, not X or IX, so exclusive and intent exclusive, and for exclusive and intent exclusive we have the write. So if we start it, we can see which tables are used. So as you can see, we don't have any writes here, but if I keep querying this, I will see some writes appearing. There we go. So it is updating this data on the target table. And at the end of the capture, I will see which tables are used and which ones are not. Okay. Another thing that I could do is analyze a whole workload. I could do that in a way similar to what Query Store does, but with more information. This all started from a blog post by Brent Ozar, and he wanted to find out which users were using more CPU on the server, and he did that by using the resource governor, which is maybe an interesting approach, but not what I would use. You can do that by capturing the queries executed on the server and summarizing the execution times or CPU or reads or writes or whatever is attached as an attribute to the execution of the queries. So we can do that by setting up a session to capture all of these. So we will capture RPC completed and SQL batch completed events, and we will use XESmartTarget to analyze the workload. Let's have a look at that. So we will use the group table appended response, and we will capture these attributes: the client application name, the server principal name, the database name, and then we will summarize CPU, duration, logical reads and writes, and the count of collection time as the number of executions. And we will use this, the snapshot ID. It is basically the date converted as a number to create an ID and summarize by the minute. So by taking the substring of the first 16 characters of the date, we are eliminating everything that goes beyond the minute, so the seconds basically. If we stop at the minute, we can get 1 minute snapshots of the execution of the workload, and we can write that to a target table. So let's try to do that and see what happens. If we start XESmartTarget, what we get is this. Let's have a look at the data that gets captured. So we have this snapshot ID, which is the current minute, the client application name, the server principal name, database name, and then we have total CPU, duration, reads and writes, and the number of executions. And if we keep querying this, we would see the numbers going up, and when the minute changes, we should see more rows getting added to this. So we have to wait for 56. And let's see what happens at 56. You see the numbers are still going up. Okay, 56. So we should get another one. Yes, there we got it. So here's another snapshot. So it creates snapshots every 1 minute, and that's a nice way to capture your execution over time. One way to answer Brent's question is this. So I just have to run a query, and I can see that my user is the one that uses more CPU. A nice way to visualize something like this is with a chart or a dashboard in Grafana. So what I will do is run this Grafana server. Grafana is a graphing application, as the name suggests. And I have a dashboard to describe that. So the output of that is, okay, loading Grafana. Admin, security first. I'll skip changing the password, admin, and that is completely fine. And here you can see you can create some charts to visualize how the workload is going. So you can break it down by principal name, as in this case, and you can display CPU, duration, and executions, and reads. So that's a nice way to visualize the data that we captured with XESmartTarget. Another way to handle the events is to send them to external databases. I will not show you this because we don't have the time and it's very niche, but it is included in the demos. This is a way to capture the events and send them to an external database. In this case, it is InfluxDB. And the way it does this is by writing the events to the standard output, and then Telegraph captures the standard output from XESmartTarget and uploads it to an InfluxDB database. Okay, I think that was it with the demos. Any questions? Questions. Okay, so I have some links for you. You can go to my blog and you have the detailed explanation of what you have seen today as individual blog posts. So all of the recipes are an individual blog post with all the explanation. It's more or less what you get in the notebook, but with more explanation. Here's the documentation to XESmartTarget. And if you have questions, I'm here, or you can send me an email. I answer all my emails with a long delay, but I do, so don't be shy. No questions? No questions? Okay, so thank you very much.